So I told you at the beginning of this unit, we're going to be learning two different kinds of solving equations with our exponential units. We learned one kind last class. That's when you raise both sides of your equation to the reciprocal power to figure out your answer. These ones are different because this time your variable is going to be in the exponent spot. So like for example, if we take a look at the first one, well, that's really big, but your x is up there in your exponent spot. It's not down below like it was last time, so we can't solve it in the same way. So there's this rule we have that if you have the same base, and remember your base is whatever has an exponent attached to it. So if you have the same base, then your exponents are equal to each other. That's our rule. So if we look at number 1, we do have the same base here. We have a base of 5 on both sides of our equal sign. So our exponents are going to be equal to each other. So we write the new equation of the exponent from the left side is going to be equal to the exponent on the right side. And then we just solve for x like we normally would. So subtract our 2, divide by -1, and we get x equals -6. So when x is a -6, those two things are going to be equal to each other. So let's look at example number 2. So again, bases are the same. They're both a base of 2. That's what has the exponents. So therefore, their exponents are going to be equal. So x squared plus 2 is going to equal the other exponent of 3x. Because I have this squared term, I know I'm going to have to eventually factor, so I want to bring my 3x over with the other stuff so that it's equal to a 0. So that gives me x squared minus 3x plus a 2 equals 0. And then we go into our trinomial factor. So I set up my 2 sets of parentheses. I still have my equals 0 there. So when we factor this, will our signs be same or different? Same. Both are going to be negative. And then what multiplies to 2 but adds together to give you 3? 2 and 1. 2 times 1 gives you 2, but then 2 plus 1 gives you your 3 for your middle. And then we set both of these equal to 0. We end up with 2 and 1 as our answers. Now, especially when you get 2 answers like that, you really want to check to make sure that they both actually work. Sometimes one ends up getting rejected. So if I plug in my 2 first, so for my x's there in my exponents, I'm going to plug in my 2 just to check to make sure it works. On the left side, what's 2 squared? And then plus 2 gives us 6, so 2 squared is 4, plus 2 gives us 6. On the other side, 3 times 2 also gives us a 6. So yes, 2 works out, we get to keep that one. So now we got to plug in the 1 to make sure that that also works. So 1 squared is 1, plus 2 gives me a 3, and then 3 times 1 also gives me a 3, so that checks. 2 to the third equals 2 to the third. So, same base, exponents are set equal to each other. Now these other examples, it's the same notion. If your base is the same, your exponents are going to be equal, only we have a little bit more work to do because this time our bases aren't the same. Here I have a 5, here I have a 125. So what I have to figure out is, can I rewrite my 125 so that it's 5 to some kind of exponent? Probably. So let's see here. 5 squared, well, I already know that's 25, so it doesn't work. So then I'm going to try 5 to the third. There you go. 5 to the third is 125. So I'm just going to rewrite this Instead of as 125, I'm going to rewrite it as 5 to the third because it's still equivalent. It's just a different way of writing it. My left side is going to stay the way it is. And now my bases are the same. Now I have bases that are both 5s. So just like above, now my exponents are equal. So then I just add my 1 over. And we get x equals 4 as our answer for that one. So this is what we call our change of base rule. You just have to rewrite something so that it's in a different base. So at number 4, I have a 3 and a 1 are my bases, not the same number. So I have to rewrite the 1. And this is the one a lot of people tend to forget. Anything to what exponent is always a 1? 0. So this 1 over here is the same as 3 to the 0. So whenever you have that kind of equation where you have a base, like for example this one, your 3 equals a 1, you just got to remember that 1 means it was 3 to the 0. Or if I'm looking for a base of 5, it would have been 5 to the 0. So now my exponents are equal because they now have a same base of 3. And then we just add our 3 over. And we get x equals 3 as our answer for that one. So then looking at number 5, we've got a base of 9 and a base of 27. So you got to sit here and think a little bit. Can I do 9 to some exponent to make it 27? No, because 9 to the first is 9, and then 9 squared is 81. So that tells me we're not going to use 9. We're going to have to change both sides. So how can I rewrite 9? 3 to the second. 3 squared is also 9. So I can change 9 to be 3 squared. And then it's still going to have that exponent of x on the outside there. So all I've done is take my 9, rewrote it in a different way. Still has my x. So 27 is 3 to what power? 3 to the third. 3 to the third is 27, just written in a different way. So now right here, I have my power to a power rule. So that just means I have to multiply those two together. So on our left side, we have 3 to the 2x now equals 3 to the third. Now we have the same base. They're both a 3, so our exponents are now equal. So we divide by 2, and we get 3/2, or 1.5. All right, let's look at number 6. So for number 6, we have a 3 and we have a 9, but the 9's in a fraction. What kind of an exponent makes fractions? Negative ones. So this 1/9 is really 9 to the negative 2. So now I just have to change 9 again to 3 squared. So I needed to have that same base there. So again, made it negative because it was a fraction. Now I've rewritten it as 3 squared, still to that negative 2 power that was on the 9 that hasn't gone away. Multiply those, so I have 3 to the negative 4. Left side hasn't changed, that's still 3 to the 2 minus x. So now we can set our exponents equal to each other. Now they have the same base of 3. We can set them equal. So subtract our 2. Divide by negative 1. get x equals 6. All right, so let's try the next one, number 7. So I already have a 4 and I have a 32. Those are our bases. So I always like to try to see if I can make the smaller number into the other one using exponents, but let's see here. I don't think that's going to work. 4 squared, 64, so no, we're not going to be able to use 4 as our base. So how can we rewrite the 4? There's really only one way to rewrite it. 2 squared. So 4 is going to turn into 2 squared. And then it's still going to have that exponent of 2x on the outside. Again, that doesn't go away. It's still there. So then 32 is 2 to what power? 2 to the 5th. If you don't remember that, you can't do that in your head, that's fine. Use your calculator to help you. Once you figure out 4 has to be 2 squared, just keep multiplying your 2's until you figure out what exponent you need to get you to 32. And again, x minus 1 is still there. So I got to multiply my exponents. So I have 2 to the 4x equals 2 to the 5x minus 5. So now we can say our exponents are equal. They're both on a base of 2. Same base, exponents equal. So I'll subtract my 5x. And I get negative x equals negative 5. Divide by the negative 1. And we get x equals 5 as our answer.